So in an organization, the number of women present are mu times that of men. So men are, let us suppose, M. M men are there. So mu M should be women. Okay. Alpha things are to be distributed among them. Then the probability that the number of things received by men are odd is so total persons are these many persons are there. Okay. Alpha things to be given to men. So any men selected out of, or you can write like M over M and MU. That is man selection. Or woman selection would be you understood what I did? Selection of a man first, and to that man we have to give odd number of things. Yeah. So odd number of things means out of alpha either one object to be given to man. So 1 by mu plus 1 and rest will be given to women. Am I right? Then you give 3 things. Don't you think so? The thing will come like this? No. 1, 3, 5, 7. Yes. What do you think so? Is it matching with the things what we you feel like? Is it possible? Yeah, tell me. So we have to go 1, 3, 5 type. Where do you stop? Means mu times this, the number distributed upon them, probability that a number of things received by men are odd. So is this. So what would be the denominator? This is the favorable case. Every time the thing will change. They want mu, not alpha. I don't think so anything goes wrong with this. So if I add them up, what will happen? You have alpha C1 mu alpha minus 1 plus alpha C3 mu alpha minus 3 and so on over 1 plus mu power alpha. Am I right? And this is nothing but the odd coefficient of binomial expansion. And for odd binomial expansion, what was the formula? I guess if you know, it was what was the even positions formula? Like you know this, na 1 plus x power n c0 c1x c2x square cn xn, right? So we want 1 minus x. If I do, and if I now subtract, I'll get this way it works, right? So here my x is mu is working as you can say the flipping around you can do, or mu plus 1 raised to the power alpha, mu minus 1 raised to the power alpha with half, and then you divide by this 1 plus alpha 1 plus mu power alpha, and you just have to compare now. You got it what I did? So this becomes 1. We got the answer as half multiplied by 1 minus this is there. So what was the part given to me as a half raised to the power alpha plus 1? Can you see this? Just compare it with your result. You get the answer. This is the answer, only I made it. This value is nothing but your half. Can you see that? Just compare it. Mu minus 1 upon mu plus 1 is equal to half. Apply componendo dividendo. 2 mu upon minus 2 is equal to 3 over 1 minus 2. Minus goes, it becomes 1. 2 goes, mu is 3, I guess. 3 should be your answer. Clear? I hope you have understood what I did. Can you proceed now? Tell me. Which one? Tell me, dear. Okay. 22nd. Answer. I think 22nd answer is 0. Yes. Next. Okay. There are two n balls, okay, in a row. First few balls are black and rest are white. Okay. Both odd in number. Okay. That you understand. So this is odd and odd. So plus is 2n. Working okay. The probability that there is exactly one black ball in one of all possible arrangements. You understand the question? All possible arrangements. So let's talk about the arrangements first. All possible arrangements. So first arrangement I take up that 1 is black, 2n minus 1 white, 3 black, 2n minus 3 white, 5 black, 2n minus 5 white. Lastly, 2n minus 1 black and 1 is white. These are the possibilities. What do you say? How to arrange them? Two n minus 1 factorial into 1 factorial they should be together, na? Okay, first few are only black. They are in consecutive way, distinct in size. That's great. Both are odd in number. Okay. The probability is 2n factorial down. This is the only way they will be arranged, right? Like this only, I think it will work. This is the way they should be arranged. Okay. And out of that all possibility, we want exactly one black ball in the arrangements. Exactly one black ball. So this will be going up. Are you understanding what I'm doing? So this is the answer which we have obtained. Now how to frame it in this way? Do you think so? It is something related to combination, something forming. This is 1 over 2n Cn 2n C1, right? This is the way only, I think. Or we have done some mistake. I don't think so. Odd means this only, arrangement will be this only, and total 2n balls of distinct can be arranged in 2n factorial ways. The probability that there are arrangements, what are the arrangements they are taking? Both are odd in number. What do you think? What's your mind says? My mind is also a little bit going in that direction, like all arrangement they are saying, na? So 2n balls we are taking and 2n factorial we are writing. That is not wrong. That is not wrong. And why I'm thinking in this way, because if we would have got it their odd summation, na, then their value is 2 raised to the power 2n minus 1. Then they will match. If this is not this way, this is reciprocal of it. But how to get the reciprocal of it? Yes, you tell. Any other way? Anybody? That is so correct. Means one black ball, 2n minus 1, 3. This is correct. But arrangement is also correct. And the total probability of individual arrangement is also correct. Okay. We'll see this if something is there in my mind. I'll just come back to this. Let's complete it and then we'll review if anything left. Next, go to the next. We will hold this question. 26. This one. There is a next set X having n elements in this. I think this question multiple times we have seen. One question last time also we have seen that way. Two subsets A and B are being formed. A and B have same number of elements. So it means that out of n, if 0 element in B, then 0 element in A. If 1 element in A, 1 element in B. Okay. Successively NCN, NCN. This is number of elements in each. Total possibility. Every element has two possibilities. Every element has how many possibilities? 4 possibilities. Either goes in A, not in B, not in A, in B, and then neither in all. So each element has 4 possibilities. So 4 power n will come at the denominator. So far clear what I did? So this, whatever we have written now, this one has one formula of binomial coefficient, if you know, 2n Cn. You know this formula? So this is the answer, which is probable possibility. Second could be this, also possible. When you expand, this won't be there, this won't be there. You understood? Okay, let's deal with the next. 26 over. What next? Yeah. Okay. OPQR is a tetrahedron. OPQR is a tetrahedron. O is origin. Okay. PQ are the position vectors of P, Q, and R. Alpha is the angle with which OP makes with PQR. Phase PQR, right? Understood. It is nothing but a plane and a line inclination, right? Then which one is correct? Means alpha types thing they have asked. So nothing, we have to just do this. Can you calculate see, whenever a plane is there, this is a plane. If I get its normal position vector, the angle between them goes off with 90 minus alpha. You know that? This is the direction of a line. Let us suppose it is, you have P in this case. So P dot n by mod P mod n is nothing but cos of 90 minus alpha, which is sin alpha, right? So we have to just get n. N only the criteria. N is normal to this plane. So normal to this plane stands for I want this. So that can be obtained as PQ cross PR, right? Is my n vector. PQ is nothing but Q minus P cross R minus P. Open it up. Q cross R minus Q cross P minus P cross R, and P cross P is 0. We can write n as P cross Q plus Q cross R plus R cross P, right? So P dot n we have to do. P dot n means this. So it is being matching over here also. This is written. This is written. Only the thing this should match. P dot P Q cross are gone. P dot Q cross R will run. P dot R cross P gone. So P dot Q